Hello and welcome to this week's video roundup. I'm Michael Marshall and I'm going to take you through some of our favourite videos from the past week. Now, unless you're an expert rock climber or you just happen to be Spider-Man, you probably find that climbing is more effort than walking. But is that the case for small animals like lemurs? Sandrine Kirstemont takes up the story.
Using a type of vertical treadmill, researchers at Duke University compared the climbing abilities of different primates for the first time. They measured the amount of oxygen consumed by lorises and lemurs of various sizes. Using the results, they estimated how much energy they used up. They found that kilo for kilo, all the animals consumed the same amount of energy. But when they compared the energy used to climb and to walk, they found that smaller animals used the same amount of energy in both cases. It was thought that when early primates evolved to exploit unused food niches, like the small twigs at the tips of branches, they were paying an energetic cost to do so. But the new research suggests that climbing to feed in trees would not have meant that they were using up extra energy.
Our next video looks at some shorebirds called phallotropes, which defy gravity every time they eat. Caroline Williams tells us more.
Here, it may look like the bird is trying to make itself dizzy, but it's actually creating a vortex that's drawing tiny crustaceans to the surface. It can't suck up water because of the shape of its bill. So how does it manage to take up water droplets filled with food against the force of gravity? Researchers at MIT created a mechanical beak to find out. Here, they placed drops of silicone oil in the beak when it was horizontal. Because of its low surface tension, the oil moved along the surface without requiring the beak to move at all. But when they put drops of water on the beak, which have a higher surface tension, the beak had to make a scissor-like motion to pull the droplets up. This also worked when the beak was pointing down, and the droplets had to counteract gravity. Shorebirds do exactly the same thing with their beaks when it's time for a feed. But they have to be careful if there's been an oil spill in the area. If their beak gets coated with oil, it prevents drops of water from sticking, and they can't eat.
Finally, we take a look at how ice stacks up on Mars. NASA's Mars Reconnaissance Orbiter has been flying above the Red Planet since August 2005. Radio waves were recently emitted over the North Polar ice cap to map out what it looks like on the inside. When the waves penetrate the ice, they take different lengths of time to bounce back, depending on the concentration of sand and dust inside. Researchers discovered that the polar cap is made up of up to 4 layers of ice, filled with sand and dust, that are separated by sheets of clear ice. They think the layers were formed from variations in the planet's orbit over a period of about 5 million years. They were also able to calculate that the crust beneath the ice is at least 300 kilometers thick, since the weight of the ice doesn't seem to distort the underlying sediment. That's all for now, but there are plenty more science and technology stories on our website. You can find out about a new project that will release classified UFO files to the public, or take a look at a gallery of curious contraptions used in Victorian and Edwardian times. See you next week.